All right, welcome to our deep dive into GPT-2. And, I know you're a software engineer, so we're going to skip all the philosophical implications of, what can we do with these large language models and all that. We're just going to go straight into how it works. Like, if you wanted to reproduce this model from the paper, language models are unsupervised multitask learners. How could you do it? What are the nuts and bolts? What are the algorithms? What are the functions? So we'll be dissecting everything from the encoding scheme to the training methodology and all that. And believe me, there's some fascinating stuff in here. Did you know that GPT-2 uses this very unique byte-level encoding method that allows it to work with any Unicode string? And even though it was only trained on English text, it can do a pretty impressive translation. But first, we got to address the fundamental question. How do you represent language in a way that a machine learning model can understand?
Well, it's a complex problem. You see, us humans, we have this intuitive grasp of words and grammar and context. But for a machine language, it's just a series of symbols. Traditional approaches would often break down text into individual words, but GPT-2 takes a different approach, using byte-level byte-pair encoding, or BPE.
TPE, is that like some kind of a compression algorithm for text?
Yeah, that's a good analogy. It's about finding the most efficient way to represent the text. But instead of bits, we're talking about bytes. Initially, the text is broken down into individual bytes, but then the model learns to merge frequently occurring byte pairs into single tokens. And this continues iteratively, creating larger and larger, more meaningful tokens.
So like cat might start as CAT, but eventually become a single cat token.
Exactly. And the beauty of byte-level BPE is its flexibility. It can handle any Unicode string, including emojis and foreign characters. It's a balance between the efficiency of word-level models and the generality of character-level ones.
Okay, that makes sense. Now, I understand that the paper mentions some specific modifications made to BPE for GPT-2.
Absolutely. So they tweaked BTE to prevent merges across different categories like letters, numbers, and punctuation. This keeps the tokenization process, more organized. They also made an exception for spaces, which are obviously crucial for understanding the structure of language.
Right, so each token represents a meaningful chunk of language.
Yeah.
Respecting the inherent structure of the text.
Precisely. And this carefully crafted input representation is then fed into the heart of GPT-2. The transformer architecture.
Now, the transformer. I've heard it's quite a departure from the traditional recurrent neural networks.
It is indeed. The transformer relies on a mechanism called self-attention, which allows the model to process information in a parallel manner, unlike RNNs, which process sequentially. It's like having a global view of the entire sentence, allowing the model to capture long-range dependencies between words more effectively.
Okay, I'm a little fuzzy on how self-attention actually works.
So imagine you're reading a sentence. As you encounter each word, you automatically connect it to other relevant words in the sentence, even if they are far apart. Self-attention allows the model to do the same thing. For each word, it calculates attention weights that determine how much focus it should give to other words in the sentence.
Oh, I see. So instead of simply processing words in order, the model is considering the relationships between all the words simultaneously.
That's right. And this parallel processing ability is what makes transformers so powerful and efficient. And as a software engineer, you'll appreciate that the GPT-2 implementation of the transformer also uses concepts like residual connections and layer normalization, techniques that help stabilize the training process and improve performance.
Residual connections, those are used to prevent vanishing gradients, right?
Interesting. And the scale of this model is pretty impressive. GPT-2 boasts 1.5 billion parameters, dwarfing smaller models like BERT. It's this massive scale, combined with the efficient transformer architecture and that clever BPE encoding, that allows it to achieve such incredible performance.
So we've got our input representation with BPE and our powerful transformer architecture. But how do we go from there to a model that can actually generate language? What was the training process like?
Well, that's what we'll delve into next. The training of GPT-2 involved a massive dataset, a carefully chosen objective, and a few clever tricks to ensure the model learns effectively.
Okay, I'm ready to dive into the training process.
Let's do it. GPT-2 was trained on a dataset called web text. It's a massive collection of text scraped from the internet.
So like a digital library full of like News articles and blog posts and Reddit comments and things like that.
Precisely, a really diverse collection of text,
Yeah.
reflecting the real world, how language is actually used.
Okay, that sounds like a lot of noise to sift through.
Ah,
How do they make sure that, they're using good data?
they used a very clever technique. They leveraged Reddit's karma system.
Okay.
So they only scraped pages that had received at least 3 karma points, which means that, humans had kind of upvoted it, indicated that it was interesting or valuable content.
So they used human judgment as a filter for the data.
Exactly. It's a smart way to curate a large-scale data set.
Yeah, that makes sense.
And the goal of training was to predict the next word in a sequence.
Okay.
So imagine you give GPT-2 a sentence like, the cat sat on the bark.
Hang on.
It needs to figure out what's the most likely word to come next.
Which would be Matt, probably.
Exactly.
So the training process is basically just predicting the next word over and over again on like billions of examples.
Yes, but it's not as simple as just counting word frequencies. The model needs to learn the underlying patterns and relationships between words in order to make accurate predictions in diverse contexts.
All right, so how do they measure how well the model is doing during this training?
They use a metric called perplexity,
Okay.
which essentially measures how surprised the model is by the next word in the sequence.
Okay.
So lower perplexity means better performance because it means the model is making accurate predictions.
Gotcha. So they're feeding the model massive amounts of text, and it's trying to predict the next word. And it's constantly refining its understanding of language based on the feedback it's getting.
That's the essence of it. It's a self-learning process driven by the sheer volume of data.
And the paper mentioned that all GPT-2 models, all the sizes they trained, still underfit web text,
Yeah,
even with all that data, which implies what?
that's right. It implies that there is even greater potential, that with even more data and further training, we could potentially see even more impressive performance from GPT-2.
That's really exciting. I think it means we're just scratching the surface here.
Absolutely.
Now, this brings us to a crucial question. How do we make sure that a model trained on such a massive data set isn't just memorizing the data, but is actually learning the underlying patterns of language?
Right. We don't want a model that just regurgitates memorized phrases.
Right.
We want it to generalize, to understand and generate new language.
Exactly.
So to address this, they use a technique called 8-gram overlap analysis. Basically, what they did was they looked for sequences of 8 words that appeared in both the training data and various test data sets.
Okay.
And if there was a lot of overlap, it might indicate that the model was simply memorizing.
So it's kind of like a plagiarism check, but for AI.
In a way, yes.
Okay.
And the findings were pretty reassuring. While some overlap existed, it was generally not significantly larger than the overlap you'd find in standard training and test sets for other tasks.
So it wasn't just a parrot mimicking what it had seen before.
Exactly. And this is particularly important for software engineers. When you're building a model, you want it to generalize to new, unseen data. Understanding how GPT-2 manages to achieve this generalization, despite its massive scale, is really crucial.
Now, we've talked a lot about the inner workings of GPT-2, but as a software engineer, I'm curious, are there like resources or tools available that make it easier to actually work with this model to integrate it into my own applications?
Absolutely.
Okay, great.
There are several APIs and libraries that have been developed to simplify the process of using GPT-2.
Okay.
For example, OpenAI provides an API that allows you to access pre-trained GPT-2 models and generate text with just a few lines of code.
Oh, that's super convenient. So I can still leverage its capabilities without having to dive deep into the model's architecture.
Yes, these APIs abstract away a lot of the complexity, allowing you to focus on building your application rather than worrying about the intricacies of the model itself.
That's fantastic. So it opens up a lot of possibilities for software engineers who may not be machine learning experts to still use these powerful models.
Exactly. And as these tools continue to evolve, we can expect even more accessible and user-friendly ways to interact with these powerful language models.
Now, we've established that GPT-2 is incredibly powerful, but I'm also curious about its limitations. Are there areas where it struggles, things that it just doesn't do well?
One area where GPT-2 faces challenges is in factual accuracy. While it can generate text that sounds very plausible, it can sometimes produce outputs that are incorrect or inconsistent with real-world knowledge.
So it might make claims that sound convincing, but are actually totally false.
Yes, that's a potential pitfall. It's important to remember that GPT-2 is a statistical model. It learns patterns from the data it's trained on, but it doesn't have a deep understanding of the world or the ability to fact-check its own output.
Right, so human oversight is still really important when using these models.
Absolutely. Another limitation is controllability. Currently, it can be difficult to steer GPT-2's output towards a specific goal or style.
So we might not always get the exact kind of text we want.
Yes, while there are techniques to try to influence the generation process, it's still an area of active research. Developing methods to give users more fine-grained control over GPT-2's output is a key challenge.
So it sounds like we have a powerful engine, but not a very precise steering wheel at this point.
That's a good analogy. And it emphasizes the importance of ongoing research and development to refine these models and make them more robust and reliable.
Okay, so we've covered the strengths, so we've covered the limitations, but here's a question I've been pondering. Given that GPT-2 was trained on this massive general data set, how does it perform on specific tasks, like translation or question answering?
That's a great question, and it leads us to the fascinating world of GPT-2's capabilities beyond just text generation. Let's explore that further.
Okay, so we've got this massive language model trained on just tons of text data. But how does it actually do at specific tasks? You mentioned translation earlier, which seems a little counterintuitive since it was mainly trained on English data.
Yeah, it's pretty fascinating. So they found that GPT-2 had the surprising ability to do translation, particularly from French to English. Even though it wasn't specifically trained for translation, it seems like it picked up some of the underlying patterns and relationships between languages just from being exposed to multilingual content, like, snippets of translated text or bilingual phrases, that kind of thing, that they found within that web text data set.
So almost like it learned by osmosis, just by being around different languages.
Yeah, I think that's a great way to put it. It really highlights the power of immersing a model in this rich linguistic environment. And, it kind of makes you wonder about the nature of language itself. Like maybe the structures of human languages are more universal than we thought, which would allow for this kind of cross-lingual generalization.
That's a really interesting thought. It makes you rethink how we learn language.
Yeah.
Now, how about other tasks, like question answering? Can GPT-2 understand a question and give you a good response?
So they tested GPT-2 on this data set called Natural Questions, which is based on real Google search queries. And while it didn't perform as well as systems that are specifically designed for question answering, it still showed a pretty remarkable ability to pull out relevant information from text and provide, reasonable answers. Interestingly, they found that GPT-2 was more accurate on questions that it was more confident about, which suggests that it has some internal awareness of what it knows and what it doesn't know.
So it's not going to replace Google search just yet.
Yeah.
But it can answer questions,
Yeah,
which is still pretty impressive for something that wasn't trained to do that.
exactly. And this leads us to another fascinating thing that GPT-2 can do. It can generate different creative text formats. They found that it could produce, really coherent and engaging stories, articles, even poems. And a lot of times the results were surprisingly creative.
Yeah, I've seen some of those creative outputs from GPT-2, like that one news article about the talking unicorns. But how does it actually do that? If it's basically just predicting the next word, how can it be creative?
Right, so it comes down to the probabilistic nature of the model and the different sampling techniques they use during text generation. So GPT-2 doesn't always just pick the single most likely word. It samples from a distribution of possibilities, which brings in some variability and allows for more unexpected turns of phrase. And then there are techniques like top case sampling, which encourage creativity even more by selecting from a pool of the most likely words, while still making sure that the text doesn't become too random or nonsensical.
So it's kind of walking this tightrope between structure and randomness. Enough structure so that it makes sense, but enough randomness to be surprising and creative.
Exactly. It's like like a jazz musician improvising on a melody. They have the basic structure, but then they introduce variations and flourishes to create something new and engaging.
Yeah, I like that analogy. Now, we've been focusing mostly on the technical side of GPT-2, but as software engineers, it's important to think about the ethical implications too. Even though we didn't get into specific applications today, I think it's clear that a language model this powerful could be misused.
Absolutely. The fact that GPT-2 can generate such believable and human-like text definitely raises some concerns, like, the potential for creating fake news or spreading misinformation. I think it's crucial that everyone working with these models, whether they're developers or researchers, keeps these ethical considerations in mind and works towards developing safeguards and guidelines for responsible use.
I completely agree. It's a really powerful tool, and it's got to be used responsibly. Well, this has been a really fascinating deep dive into GPT-2. We've explored how it works, how it was trained, all the amazing things it can do. And I think for software engineers like you, understanding these core concepts is so valuable, even if you're not working on language AI directly.
Yeah, I think it just opens up your mind to the possibilities
Yeah.
and provides a really good foundation for understanding and exploring the potential of these language models. Who knows, maybe this will spark an idea for a new project or inspire you to use some of these advancements in your own work.
Exactly. And that's what's so great about continuous learning and exploration. So keep diving deep, keep asking questions, and keep pushing the boundaries of what we can do with technology.